Values are represented using numbers or symbols representing numbers. Early counting was done using fingers, sticks, and stones. Written counting was done using tally marks. Numerical values can also be depicted on a number line. A point on the line is chosen to be the origin, and the distance from the origin of a point gives the value of the point. When there are multiple occurrences of the same values or range of values, we represent the distribution pictorially using histograms. The heights of the bars represent the number of times a value has occurred. The width is usually a chosen range of values. We can also use pie charts to represent the same information. In pie charts, the frequency values are converted into fractions or percentages. These fractions or percentage values are beautifully represented by the sizes of the different sectors. When we are interested in studying or showing the relationship between two variables, we use what is called a point graph or a scatter graph, or simply the XY graph. Here, the values are given as pairs and are represented as points on a plane formed by two perpendicular lines called axes. The horizontal line is called the x-axis and the vertical line is called the y-axis. The value pair is given as the x value and its corresponding y value and written as shown. The x-axis value is known as the abscissa and the y-axis value is known as the ordinate. On the xy graph, for each x value on the x-axis, the height of the point, xy, is its y value. Let's look at some examples. A group of kindergarten kids were asked to draw a rectangle and color it. The sizes of the rectangles drawn by them are given in the following graph. Let's answer some questions based on the information presented in this graph. What is the number of rectangles presented? There are 9 points on the graph. So, the number of rectangles presented is 9. What is the most frequently drawn length? To answer this question, we look at each length value on the length axis, and we count the number of points corresponding to it. The maximum count is 3, corresponding to a length of 12 centimeters. So, the most frequently drawn length is 12 centimeters. What is the height of the rectangle whose length is 10 centimeters? The answer to this question is obtained by first locating the point corresponding to 10 centimeters on the length axis. Then we note that the height value or the y value of this point is 7 centimeters. So, our answer is 7 centimeters. What is the length of the rectangle whose height is 8 centimeters? This question is very similar to the previous question. This time, we first locate the point corresponding to 8 centimeters on the height axis, which is the vertical axis. Then we note that the length value or the x value of this point is 12 centimeters. So, our answer is 12 centimeters. How many rectangles have a higher height than length? Looking at the length value and height value of each point, we find that there are no points with height value greater than length value. Another method is to count the number of points above the line x equal to y. This way as well, in this case, the answer is 0. Let us look at another example. This one involves constructing a graph. Construct a displacement-time graph for a ball thrown up with a velocity of 10 meters per second. To begin with, we find the relationship between displacement and time. We use the average velocity equation and the acceleration formula to get the displacement-time equation. Next, we substitute the given values of initial velocity as 10 and acceleration due to gravity as -10. We use the minus sign because the acceleration is in the opposite direction to the direction of motion. The resulting equation is s equals 10t minus 5t squared. We know that when a ball is thrown up, after some time it comes down to the point from which it was thrown. In other words, the displacement is becoming 0. In the equation we have, s becomes 0 when t equals 0 and t equals 2. To draw the graph, we divide the interval into 10 equal parts, each of duration 0.2 seconds. Here are the t-s pairs calculated for the chosen time points using the derived equation. Plotting these points on a graph with displacement on the vertical axis and time on the horizontal axis, we get points forming a beautiful downward opening parabolic shape as shown. Now try constructing the graph yourself. Hope this video was useful. For more such videos, please subscribe. Enjoy learning and have fun.